May 1st. May 1st. Yeah, unfortunately, Valen, you don't get all the emotes. I haven't hit sub goals to unlock other emotes. I think I have to get 15 subs, I unlock more emote slots, but I'm only at like 8. So, yeah. I only have 3 emote slots, and they're for the different tiered subs. So. Ooh, Matthew's getting close. I know everyone's gonna hit it like next week, and I'm just gonna have to spend the whole stream dabbing, but it's fine. It's fine. I'll be alright. Wait, they're making a Jonas Brothers documentary? Or did they already make one? Sorry, Valen. Yeah, that's weird. They're not even old. I think they should wait till people are at least old. Hi Drake. Good morning. Yeah, and or dead. Agreed. Because then they can like change the story. Yeah, no, I think the Freddie Mercury one was probably good, but people just kind of tried to. So Hollywood does this thing where they always try to ride the success of other movies. Um, so like if someone has a good idea, it will just get copied until it doesn't even work anymore. There are a lot of people that care about the Jonas Brothers, Drake. I mean, you don't get to be multi-platinum album sellers without having people care. I didn't actually see the movie, so I can't give my opinion on either movie. Actually, didn't see either one. Yeah, a lot of people liked the Bohemian Rhapsody one. Some people thought it was a little too political, but it's whatever. It's movies. Hey, there we go. We're up to a lot of people now. Welcome, everyone. Welcome for tuning in, enjoying our stream. We will be starting discussing moles. Hopefully, everybody got the homework due last night. It wasn't too bad. Yeah, yeah. Trailers are interesting when you think about trailers versus movies. Trailers can like lead people to believe different things. Is it raining? It might have started raining. Yeah. I have my sister-in-law refuses to see the trailers for movies that she's excited for because she doesn't want them to spoil or lead her to think that something's happening that isn't actually happening. So yeah, crazy. Today's May 1st. It's like watching two movies, says Weaver. Wasn't Mortal Engines terrible? Like, it was a Peter Jackson film, wasn't it? He hasn't done anything good since Lord of the Rings. Just gonna throw that out there. I can't name anyone who saw Mortal Engines. Weaver apparently saw it. Oh yeah. So that's a good thing to mention, Drake. Your canvas will be what 20 points shy of a good score. So if you got what like a 19 that or an 18, that's like a perfect score. 19, I don't remember, 18, something like that. Yeah. Well, the original Lord of the Rings trilogy was fine, Sadie. The Hobbit he kind of ruined um, by just trying to make 3 movies out of something less substantial. But yeah, so to Drake's point, from the homework last night, I should get that. Hopefully, I should be able to look at all of your submissions today and then put those into Skyward and update those. So your scores will be fixed today and you'll get those extra 20 points. The battle outside the dungeon? I don't remember that part. I like watched the Hobbit movies once and then I just put them out of my memory because they weren't good. No, the Hobbit, the movie is or the book is fantastic, and yeah, the book is amazing. The movies are terrible. Someone was saying that the Mortal Engines book is a lot better than the movie, like way better than the movie, because the movie was terrible. Um, the Hobbit, the movie with all the little guys, yes, Hunter. Uh, Yeah, well, so what they tried to do is they tried to pull in like stuff from the Silmarillion and some of the other Tolkien books, um, to try to like bump up the material as well as just add in random stuff that is from Peter Jackson's mind. So that's kind of why The Hobbit was such a flop. I could have seen 2 movies out of it. I think 3 movies was just too much. There's enough there. You could have made 2 movies out of it. Hey, that 100-bit. Oh no, 200-bit cheer. Look at that. Pretty much, Cooper. All right. We're talking too much. Let's get into the lesson. Let's get into the stuff. Thanks, Fallon, for the cheer. That's like $2. Let's go. Yeah. Okay. So, mole conversions. We've already kind of talked about the mole. So let's just remind ourselves of Avogadro's number. So Avogadro's number, as a reminder, he said that 1 mole is 6.022 times 10 to the 23rd things, right? So, yeah, Trinity, this again. Good, I'm glad, Ellie. Glad you did well in the assignment. So yeah, 1 mole is Avogadro's number of things. 6.022 times 10 to the 23rd things, right? That is a very, very large number. It's what, like septillion or something? It's ridiculously huge. And that's because the reason why that is because one mole of protons or neutrons weighs approximately 1 gram, right? So 1 mole of protons or neutrons weighs 1 gram. So you're starting to see, see how we have some equal things? We say this is equal to this and this is equal to that. That should start to seem like some of the stuff we've been doing. And so we're going to use these relationships to convert things from grams into moles into individual atoms and particles, and we're going to use that with the same method that we've been doing. So a lot of people were wondering, when does this relate to chemistry? The stuff we did kind of on the worksheet that was due last night, and this is kind of how we're going to pull it in and talk about chemistry and atoms and molecules and all those things. Okay, so continuing our trend here, 1 mole of any element weighs its atomic mass in grams. Right. This is sometimes called the molar mass. So if we look at a periodic table, bing, let's pick an element. Let's just look at oxygen. So oxygen is 15.999, right? So example, 1 mole of oxygen atoms equals 15.999 grams, right? Grams of O atoms, technically. Okay, so 1 mole of oxygen atoms is 15.999 grams of oxygen atoms. Now, of course, you could round this to 16. You don't have to write 15.9999. I was just kind of clarifying what was on the periodic table. Okay, so again, when we look at the periodic table, we want to look at the number on the bottom of the element, right? So oxygen's up here. So we want to look at the, not the top number 8, that's the atomic number. We want to look at the mass, the bottom number, 15.99. Yeah, it'll get a little harder, Drake, don't you worry. Okay, a mole of an element is probably visible to the human eye. Yeah. So if you had a mole of something, 16 grams is visible. Let's just do example element conversions. So number 1, we could just ask a question of how many atoms are in, we'll just do something simple. We'll say 1.5 moles of aluminum. Oh, yeah, Cooper, sorry, are we going too fast? Here, let me slow down. I can slow down. I'll take a breath. So, yeah, all right, so let's see, recap what we did. Avogadro's number, right? A mole is Avogadro's number of things, 6.022 times 10 to the 23rd. So normally when we talk about this things here, we're talking about atoms, right? So in this problem, we're going to use Avogadro's number to do the conversions. So we're going to change these moles of aluminum into atoms of aluminum, okay? A mole of protons and neutrons is, of course, 1 gram. Oh, it's totally raining now. Yeah, it's coming down. 1 mole of any element weighs its atomic mass in grams. This is called the molar mass. Yeah. So, Olivia, for some reason, they wanted to really help you out, and they wanted to help you abbreviate mole, and they abbreviated MOL. Yeah, Drake, you could have a mole of M&Ms. However, if you had a mole of M&Ms, I'm pretty sure, like, if you tried to keep it in Utah, the M&Ms would reach like up to the top of the mountains. Oh, that's O for like oxygen. Yeah, the mountains. Yeah, sorry, Sadie, I should have made that more clear. Yeah, it's a massive amount of things. Like, people don't realize how big a mole actually is. If all of a sudden just M&Ms started flying from the sky, yeah, no, it would be an insane amount of M&Ms. I think, if I'm not mistaken, I think if you take all the grains of sand on all the beaches on the entire planet, it's about a mole. Something like that. I'm not 100% sure, but I that's like one of the approximations. Okay, so let's set up the problem. Let's do a conversion. So we'll set it up kind of like we've set up the past problem. So our question is blank aluminum atoms. So how many aluminum atoms are in 1.5 moles of aluminum, right? And so this is where we're going to do, here, let me link something to you real quick. That'll be some fun reading. Here, Drake, read that if you want to have something to look at. I think so. I don't remember, Enya. Yeah, that is an early one. It's one of the best ones. Yeah, there's only 1 times 10 to the 21st stars in the universe, or in the universe, and so you'd have to have 100 universes to get to Avogadro's number. So yeah. All right. So to do this conversion, we simply say that 1 mole of aluminum has 6.022 times 10 to the 23rd aluminum atoms. Right? So then I think Valen said it a while ago. Oh, he's got it there. He wrote out the whole thing. It's going to be basically 9.03 times 10 to the 23rd. Right? It's just 1.5 times 6.22. So no, Xander, it's not just the fact that it's big. The significance of the number is this number 2 idea, is that a mole of protons is 1 gram. That's the significant idea. It relates how small a proton is to the measuring of a gram. It relates the atomic units to our imperials, or our metric system units, right? So it allows us to relate protons and atoms and molecules to grams, something we can actually weigh on a scale. And so that's the significance of the number. The fact that it's a huge number is a reflection of how small atoms and molecules and ions are. Okay, let's do another example. How many grams would 2.7 moles of, I don't know, let's say silver. Okay, how many grams would 2.7 moles of silver weigh? 200 IQ. Indeed. Thank you, Fiendspy. Okay. Yeah, Cooper, I don't even have the capacity to picture billions of things. I think about it all the time. Do you multiply this number by the amount of moles? Yeah, so to convert, in this case, right, we would just multiply across and we'd divide by 1, and that would give us our atoms. You put 1.5 moles. How would you do that? So you just multiply 1.5 times this. Moles cancel, and you get left with atoms. You just put it in your calculator. Oh, so I guess a little side note about how to do this in a calculator. Using exponential notation is really useful. So if you have an iPhone, you want to turn it on its side, right? So I would do 1.5 times, and then to put Avogadro's number, right, I'm going to do 6.022. But to do the times 10 to the 23rd thing, I'm going to press this EE button, right? This capital E means it's an exponential expression. It means times 10 to the power of. So if I do 6.022 and I hit this EE, that means 6.022 times 10 to the power of 23. And then I press enter and I get my 9.03 times 10 to the 23rd. Right? So this little lowercase e here means times 10 to the 23rd. So recap again, 1.5 times 6.022 times 10 to the, right, E times 10 to the 23rd equals. Yeah, no, you're good, Lauren. This is the top of the notes. What's up, Trinity? What are you freaking out about? Yes, calculators are very cool. It's a shame that you guys don't know how to use your calculators to their full potential. I don't even know how to use some functions of some calculators. Okay, so how many grams would 2.7 moles of silver weigh? In order to answer this question, right, set it up, blank grams of silver equals 2.7 moles of silver, right? Do you have to find the no, Zach, and we're going to get to that. So remember, a mole of any element has Avogadro's number. So it actually, in this problem, the fact that it's aluminum has no bearing on the problem. If this had been any other element, it wouldn't have made a difference. The only thing that starts to make a difference is going to be when we start to talk about grams, because a mole of any atom is Avogadro's number, just like a dozen of anything is 12. And so if we have a mole of any atom or element, we get Avogadro's number of that molecule. Okay. So here's the idea, right? If we look at a periodic table, okay, this is where it starts to matter. We find silver kind of in the middle here, right? Silver silver right in the middle of the periodic table, Ag, has a mass of 107.87. That means silver atoms weigh 107 AMUs. They have about 47 protons. Well, they have exactly 47 protons and about 60-ish neutrons, depending on the isotope. Okay, so we don't have to figure out the protons and neutrons. We just use the weight from the silver, this 107. Okay, and so what we'll do in our conversion is we'll say 1 mole of silver weighs 107.9 grams. Now, for our purposes in our class, you can usually just go one place past the decimal for the masses. You don't have to write out the huge thing. Olivia, that's a great question. So Avogadro did a lot of experimentation by looking at like volumes of gases and generating and doing approximations. If I'm not mistaken, he actually was a little bit off when he first found it. I think he found it as 6.03 or something. And then with later experimentation with more accuracy, they were able to narrow it down to the 6.022. Actually, when did Avogadro do it? I can't remember the year. Would have been 1811. So the first one that did it. So Avogadro didn't actually discover it. He's just proposed the idea of it. It was a guy by the name of Robert Brown who found it in 1827. He used Brownian motion. You might have talked about Brownian motion in your biology class. It's the idea that little bits and flecks of dust will actually move around when left alone. Hey, thanks for the follow, Johnny. How'd you get 107.9? Okay, let me throw it back in there. Throws Brownie at the wall. Numbers. Why did they do it? Because that we were trying to understand mass ratios. This is going to lead into like predicting amounts from equations and all these other things. So yeah. Okay, so let me answer that. Let me answer Anya's question because it's really important. Where did I get the 107.9 grams? So the 107.9 grams is the mass of silver. If we look at the periodic table, right, so this column, if we go up to silver right in the middle, silver's element number 47, and it has a mass of 107.9 AMUs, okay? So the 107.9 AMUs is the number of grams per mole. So if we have a mole of silver, we get 107.9 grams of silver. Does that make sense, Inya? So if we look at any element from the periodic table, right, hydrogen weighs 1 gram per mole, helium would weigh 4 grams per mole, lithium weighs 6.94 grams per mole, beryllium names 9.01 grams per mole, boron 10.8, carbon 12.0, nitrogen 14.0, oxygen 16.0, fluorine 19.0, neon 21.2, sodium 22.9 or 23. Hey, he's back again, shock chemist. You must end your class like right before mine is in the start. Appreciate the raid, man. Back again. Yes, Kamikaze? No, this isn't Russo's class. All right. Okay. So to do this calculation, right, 2.7 moles, 1 mole is 107.9. Again, this is from the periodic table. Right, and then we can do our calculator. So here we just take 2.7 times 107.9. And we get 291.3. Now, again, proper sig figs, we should probably do something else, but we haven't had time to talk about sig figs. I would love to have a League of Legends game. My high school team is pretty great. They're pretty fantastic. So we're down to take on anybody anytime. Yeah, just message me, Chalk Chemist. We could set something up. All right. Yes, Cooper? Number 3. Oh, of course. Yeah, send me a message. We'll set it up. How many atoms are in, we'll just say 0.25 grams of sodium? Okay. Let's see. Yeah, message. I want to see that. Hold on, I have a question. Grayson, what's your question? Why didn't we use... Oh, okay, great. That's a really good question. This question might help illustrate that, but the idea is in the silver problem, we are just changing grams into moles. So we kind of have 3 things. Let me do this off on the side here before we go to the next problem. So we have moles, we have grams, and we have atoms, right? So we can change grams into moles, and we can change moles into atoms, and we can change atoms into moles and moles into grams. You cannot change grams directly into atoms. You have to do a 2-step, okay? And so the idea here for this conversion is where we use Avogadro's number, and this conversion is where we use the P table, right? So in the first example problem we did, we changed from atoms into moles, or moles into atoms, right? In the second problem we did, we changed moles into grams. So because we just changed grams into moles, we just use the periodic table number, right? You only have to use Avogadro's number if you're talking about individual atoms. And so if you want to change from grams all the way to atoms, you use both. And so in this third example, we're going to end up using both the weight from the periodic table and Avogadro's number. Does that make sense, Grayson? No, you're good, Johnny. Just try not to distract from other questions and things. Another AP Chem. Where's your school at, Shaw Chemist? Where do you teach? What state? LA. Nice. Yeah. So we're LA. Oh, Louisiana. Oh, not LA, like Louisiana. All right, fine. I was thinking LA, California. No, Louisiana's great. I grew up in Tennessee, so I appreciate the South. No, the real LA. Hence the name Backwoods. That makes sense. Morning, Serenius. Okay, so let's see if we can do this conversion where we're going to change grams all the way to individual atoms. So in this problem, right, we're going to set it up. How many atoms? So blank atoms equals 0.25 grams of sodium. Okay, so remember on my conversions, grams, right, this has to cancel, and so we need grams on the bottom, right? So the only thing we know about grams of sodium that's going to get us closer to atoms is we have to look at the weight from the periodic table for sodium. So we got to use the molar mass, right, Johnny? Molar mass. So if we pull up the periodic table, sodium is, where's sodium? Right here, right? Okay, so sodium is element number 11, and so it has an atomic mass of 23. And so we would want to put 23 grams of sodium for every 1 mole of sodium. Autonomous, I have 2 classes of like 39, almost 40 kids. So that's why I'm teaching both of those classes kind of simultaneously. So, yeah, pretty much in you. Yeah, so in my physical class, I have like 40 kids, but since we're doing online, I have 2, so I have 80. Yeah, this is Johnny Pope is teacher aide, Johnny. Johnny, we need to play Satisfactory again, man. There's nothing really new, but we should play some more. All right, so notice we use the weight from the periodic table for sodium to change grams into moles. That's where we got this 23. We don't have a Rocket League team. Sorry, Backwoods. That's one thing that we don't have a ton of interest in at my school. So we might be trying to get one for the next school year, but not for this school year. Yeah, I know a lot of people play Rocket League, but we just don't have a team for it right now. Okay. Now then this is where we're going to use Avogadro's number. 1 mole of sodium has 6.02 times 10 to the 23rd sodium atoms. Yeah, so I'm my high school team's League of Legends coach, and I also kind of play casually. So yeah, I teach. My high school has an esports team. We're the best in Utah. Or at least tied for the best in Utah. I'll link it in chat. Sure, Johnny. Okay, so let's do the math here, right? So we've got the problem set up. We've got grams of sodium to mole. Again, this is from the periodic table. And then moles of sodium to atoms, this is Avogadro's number. So there's always the same number of atoms per mole, or the same number of particles per mole. But then this weight of grams per mole is going to change depending on the element. So if we kind of do the math here, right, we would take 0.25 times, oh, actually not times, divided by 23. And then we would times 6.022 EE 10 to the 23rd. Johnny doesn't play League of Legends. He's just trolling you. So I get 6.5 times 10 to the 21st. Okay. So we get 6.5 times 10 to the 1st. So recap, right? Yeah, but it works. So Trinity, that's a good question. I should probably use maybe at least like I could do like 6.55. I usually have. I'm gonna program. I'm gonna program the canvas to be like plus or minus 10% on your answer. So as long as you do like 2 or 3, yeah, Kate, it's actually already up. If you look on Canvas, since you asked, if you looked on Canvas and you go to modules and go down to chapter 2 part 2, stoichiometry worksheet, there it is. Stoichiometry worksheet PDF. Look at that. Okay, so again, this worksheet's not due till Thursday, of course. Best in a Boston. I don't even know if I could play it. It says stoichiometry in a Boston accent. Yeah, no, I always program it as a range weaver because I know Canvas is stupid. I actually just got a Valorant drop last night, so I will probably be installing Valorant and maybe playing. I'm terrible, though. This isn't harder, Enya. This is the same. It's just pulling into a chemistry thing, which is a little more ephemeral, right? It's a little more. It's not as tangible when we talk about grams and moles and atoms. But the work's still the same. Units cancel, grams cancel with grams, moles cancel with moles. But yeah, it's just not as tangible. Valorant is Riot, the company who made League of Legends. Valorant is their like CS:GO Overwatch take. Yeah, it's a first person shooter that's free to play, but is still in a closed beta. Okay, I wanted to do a couple more practice. Okay, I wanted to do at least one more example, maybe 2. All right, let's do another example. What did I title this letter? Make sure I'm not. Oh, right. We gotta talk about C, big letter C. Let's talk about molecules. I know, Izzy. There's just too many people in the chat spamming me. And my wife's texting me. That's fine. You can say that term. I don't care. Okay. Apparently, Trinity. Okay, so let's talk about molecules and compounds. So you're right, Izzy. I'm not. I haven't timed people out in a long time. Number 1. So how much? How much would a mole of water weigh? We're talking ratatouille. Oh my gosh! No, my webcam is attached to my computer. It's wired in by USB. I can't like take it and walk around my house. Okay, so how much would a mole of water weigh? That's the real question, right? Carry the computer. No. Bye backwoods. We'll look to set up something with your school. I know. I got to set up Streamlabs. I'm still working on it, Autonomous. Hey, Anexria. Yeah, 18 grams. Yeah, good. So Sadie's got the idea, right? So we can think about water. So water, the formula is H2O. There's two hydrogens and an oxygen. So to figure it out, we would take the weight of hydrogen, times it by 2, and add it to oxygen. So if we look on a periodic table, right, hydrogen weighs essentially 1 gram per mole. And then if we look over at oxygen, oxygen weighs 16 grams per mole, right? Over here. Okay. And so then we would just add the two together. So 1 times 2 plus 16 gives me 18 grams, right? So a mole of any compound, you just add up the elements that are in those compounds. That is an AP thing, Johnny. So let's see. Sadie's got the right idea. Yeah. So let's do a more complex one. Right. How much would a mole of sugar weigh? Sugar being table sugar, sucrose. C12, H22, O11. They're getting rid of AP Chemistry? Is there just not enough interest in it, Autonomous? Well, that's weird. Because if there's at least like 15 kids signed up for it, it should carry. Are they doing like? Do you guys have concurrent enrollment? Is that the issue? Because sometimes concurrent enrollment like competes with AP and it wins out. So if you have like the college credit classes. Zach says 342. Let's see if he's right. So we would take 12 times 12 for the carbons plus 1 times 22 for the hydrogens plus 16 times 11 for the oxygens. I think it is, yeah, 342-ish. No, hey, Johnny took AP, so he has 2 years of experience on you guys. Yeah, that's weird. That's weird that it wouldn't carry if you have enough people to do it, if you have enough people signed up for it. You just put 2 random numbers. Oh my gosh. It's 342.3, technically. Okay. All right, so let's do an actual conversion here. So how much? How many atoms? No, not atoms. Sorry. How many water molecules are in a drop of water? 1 drop is equal to, depending on the size of the drop, but it's approximate. 0.05 grams. Olivia, it's actually sooner than that. So summer vacation, if you're caught up on your classes, you should be able to be done with everything on the 15th. So the 15th of May is when you should be able to be done with everything. That's what the principal and stuff has given us, because then you need the next week to turn in all your books and turn in all your Chromebooks and get all your stuff ready for graduation and make up any missing assignments. But if you're totally caught up with all your missing assignments, then you go from there. This is a sophomore level class, autonomous. Our finals are not going to be after the 15th. You can start it on the 15th, but it's open until the 17th. That's just when it's due, Drake. It'll be open on the 15th. So if you want to do it on the 15th, you can finish it. Yeah, it's a freshman sophomore, but it's really a sophomore level class. You can take it as a freshman if you're an advanced freshman. The past 650 years, Isaac? I don't know. We're just having one final, Izzy. It's not even going to be that bad. All right, let's do this problem. And then we'll be done. I think this will be good enough. Maybe we'll do one more example. This problem and one more example, and then we'll be done. So how many water molecules are in a drop of water? One drop is 0.05 grams. So we want to know blank water molecules in... We'll just start with the 0.05 grams. Yeah, they have the order. The ordering's a little bit different in Utah. We, like a typical advanced kid, would take honors chemistry as a freshman, and then they can take all three AP sciences. They can do AP Chem, AP Bio, and AP Physics. We're not doing that final, Johnny, because we're on break. Earth Science is typically like a remedial class. All right, we found up here that a mole of water weighs 18 grams. So 18 grams of water is 1 mole of water. So similarly, as always, a mole is always Avogadro's number. I don't have enough room. Water molecules, which I know you cannot read. AP Physics it's a lot of work. You should take it. It's a good class, though. All right. So how many water molecules are in 0.05 grams of water? 18 grams of water is 1 mole. 1 mole of water is Avogadro's number of water molecules. So remember, a mole of anything is always Avogadro's number of things, right? 6.022 times 10 to the 23rd. So even if you have water molecules, that's how many moles of, or that's how many individual water molecules there are in a mole. If you have, a compound, that's how many of that compound in a mole. Don't have time by thing. Yeah. So that's why I rephrased it to ask how many water molecules are in a drop of water. If I had asked for how many individual atoms there are, yeah, then we would have to multiply by 3. But I'm probably not going to do a conversion like that. That's more of an AP style problem. And yeah. 6.2 is the same. It won't make a difference. I'm glad you got baby turkeys. Let's check if Cooper is correct. Let's see. 0.05 divided by 18 times 6.02 to 10 to the 23rd. 1.67 times 10 to the 21st. Grayson, you're dumb. No, 6.626 is... That's freaking... Planck's constant. Yeah, Cooper is correct. Good job, Cooper. Sorry, I should have given you those accolades. Yeah, everyone's like, that's Planck's constant. I wanted to do one more example, Lauren. Late chemistry. Hello, Don't Drink and Derive. Good to see you back. All right, last question. Number 4. How much would a million billion, right? That would be 1 times 10 to the 15th. Molecules of all right, Johnny, you're annoying. Why did I put 1.67 times 10 to the 21st? Because that's the answer? No, well, because you take 0.05 divided by 18 times 6.82 times 10 to the 23rd. The power goes down to just the 21st. Yeah, so that's just kind of how the math works out. So how much would a million billion molecules of... I don't know. We'll just do something fun. Maybe like... No, I want to do a molecule. Let's do carbon tetrabromide. CBr4. Way. Karen's. My mother's name is Karen, but she's not a Karen. A million billion isn't a real number. Fine. We'll call it a quadrillion, because that's what it technically is. That's what I'm saying. It's 1 times 10 to the 15th. Okay, I want to let you guys do this on your own. See if you can do it. See if you can get an answer. And then I'll walk you through it. Does AP get to learn you come up with names for these molecules? Because like carbon tetrabromide sounds... No, Olivia, we learned how to name these molecules when we learned naming compounds. Because remember, carbon, tetrabromide, tetra is the prefix that means 4. Bromine we changed to bromide. Yeah, I know, it's been a while. Applying to grad school? Yeah, I mean, I've done grad school. I should put that on my info. I should put my degrees that I have. That's a good reminder. Yeah. It depends on the specific grad school. Like all programs have all kinds of weird application processes. My master's degree was a pretty simple process, but it's a really small program. Yeah, it really depends on what grad school you're trying to get into. You done messed up, Ron. All right. So, see how you guys are going along in this. See if you got the setup right. Right, it would be blank grams of CBr4 is equal to 1 times 10 to the 15th CBr4 molecules. Now, we can't convert directly from molecules into grams, So we first have to change molecules into moles, and then we can change moles into grams. Maybe Isaac, but I trust you're in AP. This should be really, really easy for you. I don't remember what bromine weighs. I want to say 79. Yep, 79.9. So, Inya, that is the correct molar mass, right? That's the great weight. So again, this is our Avogadro's number. And this is the periodic table. Yeah, 332 is fine, Inya. Totally fine. Yeah, he said he was going to send me a message, or he or she. I don't know if it's a girl or a boy, but yeah, they said they were going to. Nice face. I know, I shouldn't have assumed. So we would do this in a calculator. We would do 1 times 10 to the 15th, right? That's a million billion. Divided by 6.022 times 10 to the 23rd times 331.6. Okay. So we could write that as 5.000005, or we could just do it in scientific notation. Oops. Which I think, oh no, it doesn't flip it. So if we count 1, 2, 3, 4, 5, 6, 7 places, we get 5.5 times 10 to the negative 7th. Okay, so on the worksheet, real quick, just so you guys kind of know, you can't do all of it yet. But you can. So you can do these first 7 problems. We're going to talk about how to do 8 through 13 on Monday. So we're talking about all this on Monday, but you can do 1 through 7. If you want something to do over the weekend and you want to stay on top of it, you can do 1 through 7 over the weekend. Okay, how did I get the negative exponent? Let me go back to that. Yeah, Cooper, you're good. I'm not going to do anything else. Let me explain how we got the negative exponent. So if we look at the calculator, whenever you have a number that is less than 1 and you move the decimal to the right, that changes the power to up. It changes it to an exponent. So we would do, let's see, so we move the decimal, right, move it 7 places this way to get it in front of the 5. So when you move the decimal to the right, the exponent goes more negative. And so that's why it's 1 times 10 to the negative 7th. Autonomous, yeah, we have a Discord for the class, and then we also have a Discord for the League of Legends team. But the class one I want to keep just as students. Bye, Zach. Have a good weekend, guys. Have a good weekend, everybody. Enjoy couple days off. I know I will. if you guys need help on homework or need help on getting caught up on anything, I'll be in the Discord this afternoon. And then, yeah, AP starts in a half hour. So have a great rest of the day, guys. And Weavers wants you guys to check your email if you're in his class. So make sure you check the email that was sent on Wednesday if you have not already done so. Bye, guys.